Today I'm going to be finishing up my series on how I wired my small model railroad by focusing on what's above the layout. Let's get started. So we're up here at the computer and I want to talk about electrical blocks, or you'll see them referred to as power districts. And this is my layout. Power districts or electrical blocks are normally used to prevent shorts in one section of the layout from affecting locomotives in other sections. They're also used for other reasons on much larger layouts, which is certainly beyond the scope of what we're looking to do here with our small layout. Power districts are separated using Atlas insulated rail joiners. You'll see that here in the orange and blue, and again where blue meets yellow and yellow meets orange. I use the power districts mainly as a source of convenience so that when I built my layout, you'll see I have the layout divided into these sections, here, on the left and Unionville, and those are pieces of benchwork that they're modular. They can come apart for expansion of the layout, which I do plan to do at some point. This is certainly not my forever layout. Should I move, whatever, each section is electrically isolated, so it can be run by itself, and all the electronics are within its own section. The other benefit is, especially here in yards where you may have a bunch of locomotives running, you can have a dedicated source of power there, so that you're not causing issues in other sections of the layout by having a bunch of locomotives running. The recommended approach is to have like a toggle switch to turn off your locomotive storage tracks just to, keep only what you need running. Certainly something that I will do in a future video, because I still have not installed those on my engine service tracks as of yet. Know that with small layouts, you may not have a need for multiple power districts, and that's perfectly fine. So let's move on to feeders. Let's head back down to the layout. Our next consideration is for our feeders and specifically where we're going to place them. I brought you over here to a rather simple but dense section of trackage, so I can go ahead and show you a couple of things to keep in mind. So when we're looking at our rail, the first is going to be distance apart on a solid rail. So if we look at the rail on the closest portion to us, it is a solid rail. It is about 9-ish feet of rail with no breaks other than our rail joiners. But however, if we look at the far rail, this one back here, we see there is a break here with this frog. And same here, we have in the close rail for the straight through track, we're going to see a break with our frog, and so on and so forth. So we do need to keep that in mind when we're placing our feeders. The other thing is we have to keep in mind the distance between our feeders. So on a straight piece of track, let's take this siding for example. This is a 3-foot piece of flex track. We'd want one set of feeders here. Again, we have a break at the frog, not on the far rail. However, the rule of thumb is no more than 5 or 6 feet in between feeders. Nickel silver rail isn't a very good conductor of electricity over distances, so we want to make sure to keep our feeders close enough together. We provide that continuous amount of voltage throughout the entire section of rail for reliability on our engines. Another thing to keep in mind is a rail joiner is a break in the track, and it's not something we necessarily want to rely on to be able to carry our current correctly through over the long term, because over time they do wear, they do loosen up, and that's going to negatively affect the ability for that rail joiner to carry current from one piece of track to the next. So there's 2 ways that that's generally dealt with. One is by soldering your rail joiners, which creates, again, a solid connection between 2 pieces of track, and that's certainly doable. The other is, which you'll see commonly referenced, is 1 feeder per section of track. It eliminates the rail joiners completely from the flow of electricity. They will still allow voltage to pass, but we're not relying on them to get the voltage from one piece of track to the next. So I did use that general rule of thumb, which is to keep 1 section of feeder wire per piece of track. It's a small layout, so doing that isn't a huge burden. It's also going to really greatly aid in the reliability of the track. One thing I did notice is I do have this section here. It's a little piece of track. We're going to put a feeder here, and I'm going to show you how I do that. So let's go ahead, bust out the soldering iron, and I'll show you how it's done. All right, so the soldering iron's all warmed up. Let me show you what we're going to be using for this project. First is going to be our feeder wire. Next, we're going to use our rosin core lead solder. And also, we are going to need our rosin core non-acid flux. Acid flux is going to just eat your track up. It's not used for electronics, it's used for plumbing. So want to make sure it is non-acid flux. And our miniature brush so we can go ahead and apply our flux. Gonna need some needle nose pliers, preferably with a groove in them, but any will do. Wire cutters, and our drill. All right, so let's go ahead and get this going. First thing we're gonna do is we're gonna go ahead and drill holes for our feeders. Gonna put it close to the rail, right in between two ties. First thing, however, safety first. Let's make sure we're not drilling into anything, any wires or electronics that we don't want to. In this case, there isn't. So let's go ahead and make our holes. Want to be careful not to hit your track like I just did. All right, and vacuum up the mess. All right. Here we go. Next thing we're going to do is we're going to run our feeder wires. With this wire, we do have to separate it. So separate a length here that is long enough for us to use. And then I'm going to use my color coding, which is the white wire is on the rail closest to myself. And I'm going to drop in enough wire and then some in order to route it underneath the layout and meet up with the terminal strips. Cut it, bend it so it doesn't fall back through. Put our wire aside. Now we only need a small amount of wire available to us to solder, so a quarter inch or so is fine. We're going to go ahead and strip that off. All right. And what we're going to do here is we're going to make a small L shape. And what this does is it allows us to make contact with the rail for our solder. So, and it also stays relatively hidden. So in the case of my pliers, they're pretty wide, so I'm only going to go about halfway across the blade there. I'm just going to twist, make a sharp 90-degree angle, if you can see that. Then we're going to make another 90-degree angle pointed toward the track. So that gives us a 90-degree angle pointed toward the track and a 90-degree angle parallel to our rail. Now we're going to do that on each side. Bend and bend. Okay, now what I have found helpful is put just a little semicircle on toward the end, so it comes out back in kind of like a letter C, and you'll see why here in just a moment. If there's any adjustment where you need to adjust the parallel wire, you could do that now while it's easier to do. Okay, so let's get our flux. We're going to put some on our wire. And this is going to help transfer the heat better amongst the solder joint and help the solder to flow better, so it makes a better, more reliable connection between the two pieces of metal that we are soldering together. Okay, there we go. For the next part, when soldering, you do want to make sure that you're in a ventilated space. Now that we have our solder, we are going to go ahead and tin both the rail and our wire joint. What this does, it makes it easy when you press the two together. There's already solder available for that joint. We're going to do both sides. And also try not to breathe in the fumes if you can help it while you are soldering. Stuff will irritate your lungs pretty quick. Okay, now we have our wires. They're tinned with in the rails. So now what we do is reach under the layout. We're going to pull those wires, and this is where that C shape comes into play. Because what that does, or at least what I find it does, is it helps to press the wire to the rail. It makes soldering just that much easier. So now our wires are pressed up against our rail. We're going to use the solder that we had tinned earlier. It's going to cause it to melt. And there we go. There we go. All right. Press it up against our wire. You'll see it melt. Okay. Last thing you want to do, just give them a little tug. Make sure they're in tight. Now that our feeder wire is attached to our rail, if you find that these wires are sticking out a little too much, go ahead and take either your wire strippers or your needle nose pliers. You can give them just a little push there to flatten them out a bit. But between painting the rail and ballast, you probably won't see these anyway, so this is just a little extra something to keep them hidden. And there you go. Nice and easy. And on the bottom, just go ahead and run it to your terminal block or your suitcase connector or whatever you're using underneath your layout. Go ahead and attach it now. And the last thing we're going to do is we do want to clean off the extra flux off of our connection here. Just using regular isopropyl alcohol. This is 70%, and a Q-tip. You don't want this anywhere near your soldering iron because you have a nice little fire, and that is the last thing we're going to want. So just want to give that a good clean on all three sides of the rail. Get that extra flux out of here. And there we go. Nice and clean. And that's how we're going to solder our feeder wires to our track. So this is going to conclude my series on how I wired my small layout. If you have any questions or tips on how to keep a cat off a layout, go ahead and leave them in the comments below. And I'll see you on the next one. Happy